Hi, this is Anson KIB190504. Today I'm going to present to you my proposed design for the circuit diagram I have designed for a gas monitoring system. So, the OM that I've chosen is differential OM, also known as difference OM. The reason why I've chosen difference OM is because, firstly, the calculation will be easier as only one OM is needed in the whole circuit. Secondly, the nature of the amplifier is linear, which fulfills the equation given in the question, which is also linear. Thirdly, is because it is able to reduce the external interference and thus avoiding unwanted signal, which is my ultimate goal, as I believe unwanted signal may affect the monitoring system and therefore causing the data to be inaccurate and result in the system to be faulty. Here is my proposed electrical circuit diagram design with the parameters of two voltages supplied, Vx and Vs, resistor 1, resistor 2, resistor that connects to the ground, Rg, the feedback resistor Rf, and also the voltage output. There are a few assumptions needed to be made in order for the circuit to work accordingly and also to find the value of the parameters needed, and they are: firstly, the OM is a balanced differential amplifier. Secondly, the values of R1 and R2 are the same. Thirdly, the values of RF and RG are the same. And lastly, the ratio between R1 and RF is the same as the ratio between R2 and RG. And after that, we can apply the formula for balanced difference OM, which is Vout equals to the difference between Vas and Vx times the ratio between Rf to R1. After completing the calculation to obtain all the parameters value, I can now get the final design of the circuit with Vx equals to 0.5 volt, Vs ranges from 0.5 volt to 1 volt, and also the ratio between R1 and Rf is 1/8. So we assume Rf equals to 80 kilo ohm and our R1 equals to 10 kilo ohm, and that's the final design. Thank you and have a nice day.